So I'm going to do a practice problem for chi-squared goodness of fit. This is like the practice problems you'll have, but I want to take it a step further and I want to show you how I'm going to solve it, and it might be a good way for you to follow. So use the following information to answer the next questions. A teacher predicts that the distribution of grades on the final exam will be, and they are recorded. So the grade proportions for A is 0.25, for B is 0.30, C is 0.25, D is 0.10, and F is 0.10. Remember, these could be the same as A is 25%, B is 30%, C is 25%, D is 10%, and F is 10%. I went ahead and made them a decimal to make it easier on me. So the grade frequencies these were the grades that actually occurred. She had 5 A's, 7 B's, 5 C's, 1 D, and 2 F's. So the first question is, what is the observed value for the final exam grades on the A, B, C, D, and F? That's really easy for me. And look, I made a table to make my life easier. So for A's, she had 5, B, she had 7, C, she had 5, and D, she had 1, and F, she had 2. All right. The expected is the one that's a little bit difficult because I don't have it expected. All I have is the proportions. So my first step is I'm going to add up 5 plus 7 plus 5 plus 1 plus 2, and I get 20. So I'm going to put this right here. N equals 20 because it's 5 plus 7, plus 5 plus 1 plus 2, and that is the sample size, okay? Even though the sample is all within all these categories, it's still the sample size, and I'm going to make this a little n because that's sample size. All right, here we go, expected. So to get the expected for A, I'm going to do the sample size, which is 20, times 0.25 to give me 5. So for B, it's going to be 20 times 0.30 to get 6. And then the next one is 20. Sorry for the comma. I'm trying to make this easier. Okay. 20 times 0.25 to give me 5. And 20 times 0.10 to give me 2. And the same for F. 20 times 0.10 to give me 2. All right, again, guess what? All my expected should equal 20. So what I'm going to do is I'm going to do 5 plus 6 plus 5. That gives me 16. Plus 2 gives me 18. Plus 2 gives me 20. So the number in your expected should equal the number in your observed, the sample size. If it's not going to like you on the website, and it's going to cause you to do things wrong. All right, so right now what I'm going to do is I'm going to go put all my values in the website, and I need to be mindful of where I put them so I don't do anything wrong. So again, here's my letter grades, here's my observed, and here's my expected. I had to give my expected the right amount of values to equal the observed. So here we go. I'm going to go to the social science statistics site. I'm going to go to calculators, and I'm going to go down to chi-squared goodness of fit. All right, so remember my categories were A, B, C, D, and F, okay? I hit next. All right, so my observed, I'm going to keep it as frequencies. Do not change it to proportions. Even though you're given them, it's going to confuse you. Okay, keep it on frequencies and you'll be fine. So this is 5, this is 7, this is 5, this is 1, and this is 2, okay? And then for my expected, it was 5, 6, 5, 2, and 2. All right, look what I'm going to do right fast. I'm going to go back to my thing, and I'm going to make sure that I have the right stuff. So my observed are the same and my expected are the same. Check yourself before you hit the calculate button, because if not, you're going to have to do it again. So here I go again. Frequencies, observed, expected. And then I pick the right level of significance and I hit calculate chi-squared. Okay, so I got some good stuff there. I got the chi-squared value is 0.667 and the p-value is 0.955, right? So it asked me back here, okay, oh, and I skipped some steps, but I'm going to go ahead and put it right here and I'll go back. I just wanted to make sure that we knew how to use the calculator. So this is 0.667 and this is 0.955, okay? So what's my degrees of freedom? This is really easy. It's the number of categories minus 1. So I have 5 categories minus 1 equals 4. Okay, and what's my alternative, my null and my alternative hypothesis? H1 is that, so I want to do it this way. So I'm going to say the proportion of A equals 0.25, comma, proportion of B equals 0.30, comma, proportion of C equals 0.25, comma, proportion of D equals 0.10, comma, proportion of F equals 0.10, okay? So that, what I did, I basically reiterate what my proportions were because they were different. So what's my alternative? At least one proportion is different. Again, that means I could have one proportion different, two proportion, three. They all might be different from what they need to be, but that's a way that I can test, okay? I got my chi-square test statistic and I got my p-value. So what would I conclude? All right, first step, I need to compare p to the level of significance, and I'm going to use the little fish so you know what I'm using just to get comfortable with the symbols. All right, so p is 0.95 is, 5 is greater than 0.05, so I fail to reject the null hypothesis. So what does that mean? That means that I'm keeping basically, or I'm saying, all right, these proportions for distribution are correct. They might not be exact, but they're pretty close. So I'm going to say at the 5% level of significance or significance level, you can say it any way that you want, the proportion of final grades follows the given distribution. Okay, what does that say? It just means that the distribution the teacher thought is how the distribution is. So we just concluded that we're basically keeping our null. We can't say, oh, I'm keeping my null. I have to say what I concluded in the end to kind of close the loop.